Record and transcribe. Okay, so it has started recording. Very good. So all of you should see the screen now. And what I was in the middle of telling you is to just open up the earlier week's hands-on, week 3, as well as the accompanying Grasshopper file. So I'll show you how to create a quick custom user object using the previous example, which we will also build upon for today's Python class. Okay, so open document. So go back to your week 3. So we can use the Esplanade example. Okay, so this is what we have done a few weeks ago. Let me just put them side by side now. Okay, so this was the end product for all of you who remember. And you also have a support structure below. Okay, something like this. And it was all done with this whole spaghetti worth of Grasshopper script. Okay, so we have the divide domain. And then we have all the other portions that created our outputs, which were this custom preview. Okay, so say for example now, what we want you to be able to understand by the end of this lesson is you can make all of this into a Python script, or you can also make this into a cluster. Okay, so that you simplify all of this into one little cluster. So how do you do that? You just start by doing this. You select all of it, click on the bottom right, and go up to the top left. And then use the middle mouse button. And instead of grouping this, which we have showed you before, you click on this folder button. Okay. So now what's happening is that it has compressed everything into this small little button here, this component here. Okay. So technically, there are two inputs, and that's because we have left this as the inputs earlier on, the UV count, and then we have this output here, which is the swatch, the surface. We can still edit our U and V counts here. Like for example, if I were to change this, I move this down. This will still adapt as it is. Okay, 3 by 3 grid. Or I can bump it back up again. So this is still parametric in that sense. Okay, so this is what a cluster does. You can always double click at the black color portion of the cluster and go back to edit portions of your script. Okay. And once you're done with that, you can click on this top left-hand corner, and I can return to parent, which is here, what I have over here. Okay, I will undo. So if you ever want to remove your cluster, you right click and you explode the cluster. Okay, so this will be all the outputs again. This was the original file. Okay. I can always change the input. So say for example now, I'm going to move this pipe radius on the left here. Just now I had two inputs, right? Which was the surface and the UV panels. Now what I'm going to do is I'm going to move out again. I will click from the bottom left to the bottom right to the top left over here. So these are all selected. I leave these two custom previews on the right. And then these are the inputs, the surface, the U and the V count, as well as the pipe. Then you press your middle mouse button for the package. Press it down and it will be here on the top. Okay, and now you have created another cluster. So it's slightly different from what I've done just now. So instead of just only having the two inputs for the U and the V count, I have it for the radius of the pipes as well. And of course the surface. So I can still edit this now. So it can go back to a 10 by 10 grid. I can also change the thickness of my pipe, the structure below, which you will see here now. Okay. And here, I can always rename my inputs and outputs because this is meant to be a user-friendly object, right? It's something that you want to think about in the beginning. That's why just now I took some time to explain to you what the course is about. Is how you can think of something complex into its simplest elements. So now what you're trying to do is you're creating your own workflow encapsulated into one little button so that you can reuse it again and again and again and again. And you don't have to waste time. So for now, maybe I'm going to make this more user-friendly to myself as well as maybe to your friends. You can right-click on this and you can change this. So this one could be you can just make it more specific, like this is my design surface. Or if you want to make it specific to your own faculties, you can call this your roof surface. Okay. Or if you are from landscape, you can say this is your topo surface. You can name it whatever you want. Yeah, I'm just going to leave it as, say, for example, topo surface. And maybe U and V count sounds very abstract. Maybe now you want to sell this, right? To your, like that landscape architecture wants to sell this to your lecturers who don't know about Grasshopper, right? So you can tell them, okay, this is count in the x-axis. Because everybody knows about x and y, right? Because that's in math. So there's x-axis, and then we can call this, for example, y-axis. And then this one, you can make it more obvious. Radius, you'll be the radius of structure. Okay. So with that, anyone who comes in and sees this, they will know what to do. to put in the inputs. You can also rename the cluster as well. You can call this the Esplanade, the Esplanade, you know, something like that. Okay, and this will be your outputs, which people can then see and then directly affect your design. Okay. And what is cool about this is, okay, I just show you what happened for Ladybug. You can see here, Ladybug has all of these files. Yeah, I'm just going to use one of them that we have done before. Say, for example, the sun part. Okay. Now I'm not showing it by the icons, right? So I can always go back to my display, draw icons. So there's an icon here that is drawn for Ladybug. There are icons here. This is the cluster icon. I can go back here and I can double click inside. And you can see that actually the entire Ladybug component, the button, right, is a Python file, which we'll come to later on in the next part of the lesson. And this icon, I can simply replace over here. So how do I do that? There's two ways to do it. I'll show you the easiest way first. You select this new cluster that you have created and go to File and click on Create User Object. Okay, I'm just going to leave this here for a while so everybody knows. So you have to click on your cluster, make it turn green, go to File, and then click on Create User Object. This is the interface. I've also done it as a PowerPoint. Here. Okay, which is inside your module, so that you can go back and refresh this later on. Okay, under File, Create User Object. And these are the next steps. So, this nickname here is the name that you will always type to when you double click on the canvas and get the shortcut. Remember, all along throughout this course, I always tell you to double click on the canvas instead of trying to click from here, because the amount of time that you spend to keep clicking here is a waste of time. So the name should be the Esplanade, yes. And maybe your nickname, you could just call it the ESP. So that next time when you just type ESP, you will directly come up in your shortcut. The category here, it will create a new user category here. And you can even create subcategories. Okay, so this one is, I will leave this to you to explore. I will not further complicate things here. This is the part where I'm talking about the icon. Okay, so this is the current icon image. You can choose from a file where you can download icon files on the online, or you can just reference your icon library. Okay. Oops. So if you were to double click here, but sometimes my cursor is too big. Show icon library. Okay, let me just bump it back down first. Okay, see? I don't know why, it's just the cursor thing, okay? So, but when you double click on that, right, you can see the entire library of icons that you have loaded into your computers. And you can choose your icon accordingly. So for example, now I will choose something that is relevant to the Esplanade. Maybe something like this. Oh, but that was used as a construct matrix. Okay, but never mind. I'm just showing you as a rule of thumb, and I click OK. And then what will happen is you will see here. Yes, you can choose any icon for now. And then you go to use. You will see that there will be a new tab here called User. Click on this, and this is your new button. Okay, I can click here and put it on the canvas, and it looks like something that is done from Grasshopper itself. Okay, so you all can go and cheat your other lecturers. You can sell this on, I don't know, Fiverr or Etsy or whatever. And they can just input their own surfaces. Like for example, now I will just put this in. And it already has its default value of 0, 10, 10, 10, and radius. So what I can do now is I can disenable this. I right click, disenable. I also put this to the domain. And you can see that it's showing up. Okay. So you have created your very own new custom button. And I told you there's two ways to do an icon, right? Another way. Oh. Okay, I don't have Illustrator on this computer, but you can go online and you can essentially, as long as you create a 24 pixel by 24 pixel image, which I've also written here in the notes, as a PNG in Photoshop or Illustrator, you can drag and drop that image there. So what I'm going to show you is I'm just going to download any 24 by 24 thingy. I hope this is 24 by 24. Okay, this is 32. I think maybe it may not work, but let's try. Sunshine icon. Okay, so this is my sunshine icon. If it's 24 by 24, you can just drag it and apply it here. Okay. So you need to convert it to a 24 by 24 file, which I don't have Photoshop here to do it at. Okay, but you all can try. Okay, just do a 24 by 24 pixels file in Photoshop, and you can definitely drag and drop and replace the icon here. Otherwise, you can also, like just now in the custom object portion, file, edit, create user object. You can save it. You can browse for the icon files. Oh, yeah, I delete it. And then select the icon file. I think it doesn't detect it because it's an ICO file. It's just showing PNG, BMP, and GIF, JPEG, and TIFF files. Okay. So all of you clear on how to create this custom user object? If you want to edit your custom user object, you can go to File, Special Folders, and User Object folder over here. Okay, and this is where your custom user object is. So you'll realize that all the Ladybug folders are inside here now. Because as I just mentioned to you, it was created with Python and then repackaged into a UX. So this was our Esplanade. If I were to just delete this now, you'll realize that it will be deleted from your Grasshopper canvas as well. So sometimes when you make a lot of buttons and you don't want them anymore, you can just delete from here. Alternatively, so for example, you want to sell to your tutor, right? You will just go back to the folder just now where you have created it, the Esplanade. You copy and send it to him. You can email to him or her and tell him or her to just copy and paste it into this folder in their Grasshopper file. And then it will work. Okay, you all can try now with your friends. Okay, you can create your own custom user object, send it to your friends, and then they can download it and put it into this folder. And when they open up their Grasshopper interface again, you will see that as a custom button. Okay, so that's essentially what we want to do for this exercise for you to submit by next week. Okay, the rubrics are all clearly put up here. You can take today's session with your TAs to discuss further with them on how you would like to create your custom user object. The first 4 rubrics elements are giveaways. The last one is the most important one, which is the appropriateness. Okay, so what do I mean by appropriateness? You don't go and create another icon that just creates a very simple, for example, you create like a addition. So you add, like the inputs is a slider. Okay, so it's something like this, A plus D, and then maybe it's something like this, right? and you add three numbers together. Then you have an output. You always need to have an output. So this is your output as a result. So you do this, then you cluster, and then you right click. No, then you select this file, create custom user object, and then you call this the header, and this is the header. Okay, I will show you this as a nickname. I just call this AD. Then you choose your icon. Okay, you have to be very careful when you double click and then don't move. Because that screen always moves away. Ah. Okay, so maybe I'm just using maybe you use this fancy pie icon here and click OK. Right, so now you have created this nice button here. Right, and then you have this results. So this is not an appropriate custom user object because essentially you're just creating a very simple thing that adds three numbers together, even though it works. Right, so you get the result 27. Okay, you have a fancy icon here. This works, yes, but as part of the rubrics, yes, you will get 80%, but you will not get the full marks up because you're just doing something for the sake of doing something. Ideally, it should be something, it should be a custom user object that will help in your own workflows. So if I were to think about it for landscape architecture, it could be something that will help you create a surface from points, which we have shown you earlier on in one of the tutorials. Or you could plant trees, right, at certain points. Or for architecture, you could generate columns, right? Or you can generate structure or a sunshade or do a simulation. Okay, so this is what I mean by appropriateness and what are the negative example. Okay. Everybody clear about this custom user object? All achievable, right, for the exercise next week? Okay. This one? Oh, you just need to create a number as an output. So let me just so if I were to explode cluster again, so this is a number. So for example, even like this geometry here, I can explode this. The end result will be surfaces. Okay, so this one is surfaces. So you can collect all of them as a surface. Right, and then I can make this into another cluster again. Wait, move this away. And I will also move these numbers away. Okay. The important thing is because there has to be an output for the cluster. Right. So here we also have this output for the surface. Yeah, that's for this cluster. But then for the numbers, right? If I were to just take this, okay, I delete this, right? I take this alone, and then I make it into a cluster. You see that here it becomes a jagged edge because you are not giving an output for it. Okay, I repeat again. This was our simple exercise to add three numbers together, right? Then what I did just now was to create a number container, connect this out. So very clearly here on the left, this is the input. This is the actual cluster. And this is the output. Okay. You always need to have an output and an input before you create a cluster. Otherwise, like in this case, if I didn't have this, I'll just disconnect this first. Okay. I will take this. It's the same cluster, right? Middle mouse button, create cluster. There's no output. It will do what you want it to do, but you don't have it connecting outwards. Now, if I were to have it connect to an output, and then I create the cluster, it will know that it wants you to output to this value. So that in future, this one can be connected to anything else. It could be connected to a panel. It could be connected to something else downstream that you want to create. Okay, and the whole point of this is, again, as I'm going back to the whole course, right? We want to let you think for spatial computational thinking. So this is the part computational thinking, right? You break down something very complex into its elemental parts. And from then on, be able to use these little portions to help you in your design. Okay, so in the beginning, it was all very simple using the Grasshopper portions. Then we tell you how someone else has used Python to create a plugin. Now we are teaching you how you can even create your very own plugins, something that you can automate your life with. Okay, and it could be done either by using whatever commands that were existing in Grasshopper, or something that we will do in Python shortly. Okay, so if you all have no questions now, we will have a short break, 14-minute break until 10:15, so that you all will be fresh for your Python part. Okay, go and buy your coffee because this part will be quite taxing for most people. Right, we will talk about how you can create whatever that we have done just now using Python only. Okay, so we will reconvene here at 10:15. Those who have questions, you can quickly reach out to your TAs on the bottom right-hand corner.
You have to see it if you want. Well, once you go to the
Okay, 10:15 already. Let's start. So we're going to start off with a lecture portion first, and then concurrently go to this lesson 8 and download these 4 files. Okay, list, dictionary, quad, and triangle. So I'm going to go through this. Okay. So essentially, what we are going to share with you now is Python scripting. Why we find it important for you to at least understand Python scripting is so that you will be able to know the power of being able to code, right? Which will let you customize a lot of things. Okay, and once you are comfortable, okay, let me take a step back. There are probably 2 different kinds of categories of students here. Okay, one will be those that likes to design and knows that there are this kind of options like Python, and maybe you can work with other people who will do that and use that in future for your respective careers. Okay, then there are also another category who will feel very comfortable with using this, and then you can push forward with understanding design with Python and move on to other programming languages, which I will come to later on. Okay, so it doesn't matter whether you are the first category or the second category. At least for those of you who are in the first category, you know that this exists. So that next time, if you go out to your respective firms or you start your own firm, you know that something like this can work and can happen. And so you're not limited to just always building or designing the same boring thing again and again and again. You know, those concrete ephemeral thingy. Okay. So why do we want you to understand this? Okay, we just show you this geeky thing. Okay. Some of your feedback in the mid-semester review was to talk about something biomimetic. Yes, we will come to it now. You know, it was always the intent. You'll realize that a lot of designs that you see evolve, like you yourself as a human, you are a result of evolution. Sunflowers are the easiest for you to relate to in terms of the beauty of nature and the logic behind it. I'm not even going to talk about mathematics. It's just the logic behind it. Essentially, the way that the beautiful sunflower is positioned, right, is the most efficient way in which you have respective spirals that gives you ample space between each of these little elements here. Okay. And the basic logic is the Fibonacci sequence, which is, if you were to think about it in a very simple sense, you just add the the last two numbers, I mean. So if you start off with 0 and 1, when you add these two together, it becomes 1. When you add 1 and 1, it becomes 2. When you add 1 to 2, it becomes 3. And so on and so forth. So that's the simple logic of it. And that's how you can get this from this simple logic. With Python, it's just this very simple few steps. Okay. And the thing about Python is that it allows you to pick up programming logic much faster than if you were to learn another programming language, for example, C# or Java, because it's kind of the closest to the English language that you have. So you just need to make sure that you understand this logic. So you're just taking the first two numbers and you just add it while you are looping it again and again by adding 1 to it. Okay. So this is how you can achieve something beautiful with a simple code. And how does that apply to us practically? Okay. So for example, this project that I done when I was SUTD, right? It could have been done in Grasshopper, but it would have been very painful to do because you will see that there will be a lot of spaghetti straps, right? Like what you saw earlier on. If I were to explode this is just to create a very simple Esplanade with a very simple, consistent spacing of the dimensions, as well as panels, right? But if you were to look and scrutinize what we have done for this, as I mentioned to you all before in the lecture, right, there are 13,000 unique panels, and out of them, there's 16 different kind of configurations. And there's inside and outside panels, right? So to be able to do this in Grasshopper, you can do it, but your host definition will be very long. But in terms, if you were to set it up as a Python script with different functions and different classes, you can do this with maybe less than 100 lines of code. Okay. So that is the beauty of you being able to understand. If you are in the first category of designers, at least you know this exists and you can achieve this. Okay. Then you can tell your minions next time to code this for you. If you are in the second category and you would like to learn more and you are already inclined, you understand the concept, like you're kind of like me, you try to understand why this looks like this. Then you will develop your skills. I'm teaching you Python now. You can move on later from Python to C#, and then from C# to something else. Okay, there's a lot of other syntax. But as long as you understand the logic, you can pick up any programming language very easily. And if you know Python, you can apply it to other fields as well, like data science, which pays double what architects earn. Definitely. Okay. So as I've said, this is a good stepping stone for you to understand. So let's go back to the lecture proper. Okay. So for me, this Esplanade existed when I was in JC, and I liked it a lot because I thought it was super cool. Not because I like to eat durians, but I just thought that it was so cool that, you know, there's this giant structure here, and they have different heights of the panels, and when you're inside, it still looks very nice and aircon, and yet you feel the natural daylight. Okay, so then I think to myself, like, how did they manage to pull this off? Like when I was 17. And that's why I went to intern at this place, DP. And I realized that what they did was a very conventional way of doing it. They had a drawing list of many different configurations. So at that point of time, I don't even think they did use a digital generation technique. They have a digital modeling technique, but not a digital generation technique. And I thought to myself, how can you simplify this into its simplest components? Okay. So essentially, that's how I've crafted the earlier tutorials. Because essentially, what this is a rectangle that is split into two triangles. With the midpoint here, you move it up, and then you create two more triangles. You can use the base of this triangle to create the structure that we have shown you just now earlier on in the Rhino file. Okay, and that's how we did it in Grasshopper. But now, if we are to do this in Python, I will show you the class file later on. You will create that product within one component and just a few lines of code. You will realize that it's less than 30 lines of code. And if you take this next step to go from Grasshopper, which is a visual learning, it's a graphical algorithm, to something that is like this, which is scripting, it allows you to do so much more. In terms of the comparison, for Python, as I mentioned, it's a high-level language, so it's closer to English language. But that also means that it compromises on speed. Okay. For Python, you do not need to declare what kind of variables that you have. Okay, this may sound a bit advanced to you, but just next time when you all play this video again, you will realize that these are the differences between Python and C#. When you are lazy in Python, you don't declare your variables, meaning that you don't say this is a number, or this is an integer, or this is a floating point or a string. That means the computer will try to guess it for you. And therefore, the computer will take time to guess. And therefore, it will run slower. In other lower level languages, for example, C, where you need to declare every single thing, then it will run much faster and you will therefore be much more efficient than Python. But the cool thing about Python is that it's cross-platform. So you can use it in Windows, Mac, or Linux. But for example, C#, it is something that is entirely in Windows ecosystem. And the cool thing that I've also mentioned just now is that Python has many libraries, especially for data science. So you can use that to branch off into other avenues. Okay, I can see people struggling to keep awake already. So now I will just run through this very quickly. So as I mentioned, this is cross-platform. These are the level of commands that you can call upon within Python itself. If you want to go even further, you have to go, like I mentioned, to C# or C++. Okay. In Python, as I mentioned, there are libraries. So you can call upon the Rhino script library to do certain commands in Rhino, or you can also call upon the Rhino common commands. You have the inputs and then you have the outputs. This is the interface. These are all the commands that you will have. They are all available online. A common question is, Aloysius, how do I know what kind of commands I need to use? I also didn't know when I first started learning. You just do it with experience. You have something you want to make, and then you try to figure it out, or you can post onto forums. There's no person that I even know of, even the person who wrote Grasshopper, like David Rutten, knows every single command in Rhino or Rhino Common. Okay, and there are different ways to do one single solution. So just have to keep at it and you will get which commands will give you the best result. Okay, this last slide is the most important because this will let you understand the logic of what we are going to do later on. Okay, so just try to have this slide open as we have it to the respective files as we progress along. Inside of the group chat, I have put in two resources. Okay, one is for Python. Okay, because what we want to, how I try to share with you all is for you all to have a direct output that is very relevant to your architectural or landscape design career. That's why I have this like a sun sheet. Okay. This person, he has created this series of YouTube videos that show you and explain very slowly what a variable is, what loop functions are, all the technical portions for Python. So if you are interested, you can go in and find out more. But mine is like more like a crash course. And as I mentioned, once you are comfortable with that, you can move on to C# in Rhino because that is significantly more efficient. For this, we did it in Python and it was good enough because we are just managing one project, right? If we have multiple projects or if you were to do it for like a Zaha Hadid building, right? You have the Soho building in Beijing is 10 times bigger than this. So you wouldn't use Python anymore. You'll need to use C#. Okay, because this lady, she was from, she has started her own practice, but she was from Zaha Hadid, Sumi Ham. Okay, a very, very smart lady. So you can also move on to this after you are comfortable with Python. Okay, so I'm just showing you all the respective trajectories that you will have once you sort of understand and know how to use Python. Okay, now let's just start with Python proper. We will need to go back to this and make sure you have all these 4 files downloaded. And I just want you to open them up so that you don't get overwhelmed. Okay? The key thing to always learning new things is so that you don't get overwhelmed. Even if you do, you try to manage yourself so that you don't, dismiss it. Because once you dismiss it, you will never learn it. Okay? So you have this file. What you just need to have is also the accompanying Rhino file, which I've also put inside the module, which is here, right? If it still doesn't work, you just need to right click and set one surface and set the surface itself. Okay. And this is the code. This is the Python code to generate all the points. Okay. So what I'm using here is a for loop to generate the points. Okay. And you will realize that it's exactly like our Esplanade tutorial. Do you remember we used the deconstruct brep command to get all the vertices of this surface? Okay. And we use the list item to extract each element of the file here. So it was 0, 1, 2, 3. Okay, that's just a refresher. What we are going to do with just a few lines of code. So I will just do a side-by-side comparison. Okay, so this is what you learned before. I'm going to apply this on the same surface now. Okay. So we did this deconstruct brep after we have the divide domain and the isotrim, and then we did the list item to focus on each of the respective portions. So if I were to go here and click here, this is the part, right? So what we are going to do in the next few minutes is to be able to get all of the points, all of these points that we managed to achieve with these 3 steps in Grasshopper. Are you all still with me? Still with me, right? Yeah. Yeah, Esplanade one. No, it's the Esplanade one in week 3. Huh? You don't need to have it open. I'm having it open so that you have like a apple to apple comparison. Okay, so what you have just downloaded here, you see this one? It's the same thing. Okay, but you do that, you do whatever that we have just done in this 10 lines of code. But these 10 lines, I also have spacing. Okay, and I'm just going to introduce to you 2 concepts for now for Python scripting. Okay, I will teach you what is a list, which we already roughly understand from this example. Remember the Esplanade example where I used the list item? I gave a cheesy analogy about the shopping list, right? Where you go and buy something, the first thing, second thing, third thing. So now we want Python to create a list and then we want it to loop within all of the points of the surface and generate a point. Okay, but I don't want to confuse you first with regards to that. I just want you all to do from scratch first. So I just want you to go File, New, and we just introduce to you what is a for loop. Okay, so you double click on the canvas and you can type Python. Okay, this is an empty new Grasshopper file. Okay, and this will be your Python file. Yeah, new Grasshopper. Okay, so this is your brand new Grasshopper file. You can double click on it. And this is all of the syntax of it. Okay. So remember in the notes, there was this portion that says that there is Rhino script syntax. There's also Rhino. See, Rhino script as RS or Rhino common as Rhino. So we are just doing this as of now. We are importing this library and the abbreviation is RS. We'll just do a very simple for loop first. Okay. So just type FOR for and then if you are confused, right, at any point of time, always have the reference file here. Okay, just in case you type wrongly. Okay, so I'm going to create a loop. So for example, for I in range. So what does this mean? When you type a bracket, right, this will prompt a help for you. You can scroll down and see what they are trying to explain to you. You can have two inputs, or you can even have only just one input, which is the stop. For our case, we want to have a start and a stop. And this range, right, is just a method, a function in which Python has already programmed into its system. It's like a syntax. So I'm just going to say that for I in range 0, comma to 10. So this is the start and the stop. And then close bracket. And then remember to do these two dots, this colon thing. Okay. And then I will just put there A equals to I. Okay. What do you realize? After you press the colon and then you press enter, you will see these four dots. Okay, these four dots is called indentation. For programming, especially for Python, it's a indentation sensitive syntax. Whatever that is indented here will be looping within this sequence. You will find that later on, for the points, we will be indenting both of them together. So it's a nested loop. But don't need to worry for now. Just understand that you always have to put this within the indent of a particular method that we want to have. And then now I just want you to type print A. Okay. So for I in range 0 to 10, A equals to I, print A. So what does this mean? This means that for I is this temporary placeholder. It's just like a counter. So you count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then A is a variable that you create. For Python, when you have an equal sign, that means that you are assigning it a value. So you are assigning the value of 1 to A. And then you are asking Python to print it. So we test, and you will realize that these are all the numbers that it has created. So take note of something, okay? This is important. What it has done, right? It has printed from, it started at 0, but it ended at 9. So it will stop before this last value. Okay? Which is why later on you will realize in the code that we have over here, there is num_u plus 1. Okay, later on I will show you graphically what this means. Okay, but do you all understand now what this is doing now? And everyone has typed this in. And okay, so essentially what you are doing is you are telling the computer to keep repeating something for 10 times, but from 0 to 10. So it will start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. As I mentioned, there's a even more in-depth explanation from this guy's YouTube tutorial here. So you are very interested to find out more, go and watch this slowly. Okay. But in the sake of time, as I mentioned, this is a crash course. As long as you understand this loop, now what we are going to do is we are going to apply it architecturally. Okay. So we go back to this diagram. Okay. We have our surface, remember? And we want to split it up into all of these modules from U and V direction. Right? Correct? So we need to take the surface and divide it in a U and V direction. So that means we have to use this same step of looping, but in the U and the V direction. Okay? And additionally, we want to be able to manage all of these commands and all of these points accordingly. Okay? If you understand, this is using I and J for now, right? From a graph point of view, okay? This first point could be 0, 0. And then this next point will be 1 and then 0. Right? This is like secondary school math. And then this point will be 1, 1, and this point will be 1, 0. Okay? And so that's how you have a logic in terms of just using graph numbers. But if you were to think of it in a more abstract sense. Therefore, this one is I comma j, and this one will be I plus 1 j. Conversely, this will be I plus 1 j plus 1, and this is the opposite of this, right? Because you are only incrementing in this direction, the j direction. So if you were to apply this now over here, just take a look at your example file here. You see, what we want is we want Python to read in the input values of the number of divisions. And then we want to add one more to it because we realize this shortcoming, correct? It will not go to the end of your point because of the way that this is starting to count. So that's why we need to have it plus 1. Okay. In this direction, and then nested in this direction. So and after you keep repeating this, you will get all the points by using this method called the evaluate surface, which takes in an input of a surface, takes in the original length of your surface, the original length of this surface, divided by num_u, and takes in the original length of this surface and divide it by num_v in an abstracted sense. Okay. So before we even type it out, I just want you all to understand this concept side by side. Maybe, okay. It's more important to understand than to be able to just type this out and have it to work. Okay. Okay, so this part here in num_u, right? It will keep trying to loop between these points. Right, and it will keep going in this direction. Okay, so just think of it as, imagine if it keeps going in this direction for this amount of times. And it just keeps going here, right? And then after that, you will repeat it in the other direction. Okay, so that's how it keeps creating the point within this surface itself. Did you all understand now? Or you just accept the fact that it will first go in this direction, and then when it's nested, it will go in this direction, in this other direction. And then with all of these numbers, you will get the respective points. Okay. So another important thing is you can do comments. You see here there's this green color thing, right? This is a comment. This is also a comment. So this green color thing does not run at all. Okay. It's important to start to comment so that you know what you are doing at each step. So this comment in Python is hashtag. So what we want to say here is I want to loop for points. Okay. So the first part here for I in range 0, I want to create a variable called num u. Okay, this is just a variable that I'm setting up. I'm not going to add one first so that I will show you what will happen if you don't add one. Okay. So the first one is looping for u. I'll just create a comment here. And I will now loop for v direction. Okay. And this is where my nesting will come in for j in range. And another cool thing about Python is that you can copy and paste. See, I can take this whole thing, I can copy, I can move this back here. Then you won't make any mistakes. And enter. You automatically again nest this for you. So this is where you will create your next step. Next comment. I want to create a point. And I create a variable called point equals to rs. So I'm using this library called the rs. And there is a method here called evaluate surface. So you can see here that this is auto trying to complete it for you. What we want is the surface. So you click here, when you double click, and you open the bracket, it will give you the hint what it needs for this particular method function. So it needs a surface, which we are just going to call srf. And then the u and the v coordinates. So that's where we have what we explained to you about the logic, right? It will be for I divided by num u, and then j divided by num v. Sorry, this one should be called num v because our u and v direction has different subdivisions. Okay, I can remove this printing because this doesn't work anymore. And the important thing is after you have created all of these points, right? You want to create a list of points. That's what we did in Grasshopper previously. So I'm going to put a dot append, and I'll append all of these points into this list. But like I mentioned right in the beginning of the lesson, right? I need to tell Python that I'm creating a list. And that's where I'll just put a comment here again. Create a list called A. So you just put there A equals to bracket. Let me just compact this down so that you can see the whole code. You have to put this earlier on because Python needs to know that you are creating a list now. Okay, my list is called A, and it's going to loop first time in the num_u direction, next time in the num_v direction, and then it will evaluate the surface and append all of these points to this list. But right now it won't work because if you notice from your Python script here, this command here, this is still called X and this is still called Y. What we want as an input will be the surface input, then the num_u, and then the num_v, which is why you need to add here and right click and call this the srf. That's your first input. Then same thing again, right click. This is your num_u. And the next one, right click. This is your num_v. And your output is still your list a.appoint point. Okay, so now you have apple to apple because whatever that you have declared here, num_u is here, num_v is here. Just remember that Python is case sensitive. So whatever capitals that you have to be consistent. Okay. A common programming convention is that lowercase is to describe what this is, and then the uppercase is your placeholder. So for example, this is a number, and this is in the U direction. And this is a number, and this is in the V direction. Okay, so I will just click OK now, and it's going to be an angry bird because you have no inputs, right? You're not telling it what surface and what num_u and num_v. So same thing, create a surface. It's exactly what you have done for your Esplanade tutorial. Right click, set one surface, set this as a surface, connect this over here. And you need sliders, right? So I'm just going to make a simple 10 slider. Control-C, Control-V. And connect this over here. And it's still angry. Why? So this is kind of like your girlfriend, right? You go and buy chocolate already, still angry. So you have to test the limit. Then, okay, there's something wrong here. It's supposed to get an integer, but it got a float. So why does this happen? Because Python is also wary about what kind of input that you put here. Okay, when you go over here, this says that it's a gh_doc object. You need to right click over here, type hint, and make sure that this is an integer. Okay, so it has to be very specific. And you have to repeat that for num_v as well. Type hint, integer, and then now it's happy. Okay. And then you will realize that it's doing it all over here. Why is that so? Because it does not understand that this surface has to be re-divided. So what you need to do is you will right click and re-parameterize. Then this is how it will re-divide the entire surface properly. So that's again another step where you need to right click and select re-parameterize. Okay. So I repeat to you why it was not functioning correctly. You need to go to num.u, right click, and type hint, make it into an integer. Repeat the same thing for num.v. The logic behind this is that to the computer, a number is not just a number. It can be an integer, which means that it has no decimal point, or it can be a float, which means that it does have a decimal point. When we do a loop, like you see over here, if you look at the help, it always needs an integer because you need to count in integers, right? You count from 1, 2, 3, 4. You don't count from 1.1, 1.2, 1.3, 1.4. You'll confuse the computer. And you'll realize here that this is the part that I purposely left out, remember? I didn't add the +1. And that is also why I was showing you in the example just now to look for numbers from 0 to 10. It will stop at 9 because it will always stop before your final number. So that's why here, if I were to just go back and press +1, and similarly here for +1, and then I test again and click OK. And now you'll see that it will go right to the end. Okay, I'm just going to open this up again. I'll arrange it properly. Okay, I'll double click here. And I will show you the code. Okay, and I'll repeat to you again what we have for today, and then we will proceed with the rest tomorrow. Next week. Just understand, right? Firstly, what we have told Python to do is we are creating a list. Okay, this list is the same as in Esplanade where we created a list item to identify point 1, 2, 3, 4. Okay, so it's just a placeholder. We have a loop, and we loop in the U and the V directions. After that, we use the evaluate surface to create the point. We have the input of a surface over here. And then we divide it by its length over here and here. So this is the portion where it will show its position on the surface. And then I append all of these points into the list again. So it's just like going through, this is the first point, second point, third point, fourth point, fifth point, sixth point, and then start from here again, 1, 2, 3, 4. This is what this loop is doing. Step by step by step by step. Okay, and then in order to correct the errors for here, what I needed to do was to right click, type in, and tell it that it's an integer for both of these variables. And for the surface, you just need to right click and you need to reparameterize over here. Okay, and that's essentially it for this week. Next week, we will repeat the same thing, but we will introduce to you the concept of a dictionary. Okay, a dictionary will let you fine tune into which point you want to control. A list goes from start to bottom, so it's a bit hard to organize. Dictionary allows you to index your information. Okay, even if you don't understand now, it's okay. Just understand we can create a list first, and we can convert that list to a dictionary next week. Okay. So all of you should have this. You can go to your tutorial now with your TAs. And if you don't understand, you can ask them about it, especially for the exercise. Okay, the exercise should be quite simple and straightforward, right? All can understand, right? How to create a cluster, how to customize it. Okay, so I'm just going to click OK now, and you can save this file. So one caveat about just now, right? Just now I created this adder thing. If I double click and I just type AD, that was my nickname, right? You can see here my adder is inside this canvas already. So that's what the nickname does. Whatever you put as abbreviation for the nickname will be where your component will come up. Okay. So you can tell all your friends to come next week, because this one is important for you to understand to create a Python script. Then next time you can do your own stuff here. And it'll be much more powerful, much more faster than if you do Grasshopper. Okay, so you all can all reconvene to your tutorial venues, and I will stop the recording. Please remember to tell your TAs about your assignment preference. I know someone mentioned about year 2 deadline, so you also have to voice out. Okay, I stop recording.